Hello friends. So, this week our discussion was more or less focused onto the wastewater characteristics and the different parameters that are used to define the wastewater characteristics. We did discuss all the major parameters almost, and then of course there are endless, there are many more other parameters and new parameters are being added on. So, these parameters are typically used to quantify the quality of water. How is the water quality in terms of these different parameters? What is the value of BOD? What is the value of DO? What is the value of COD for say? And based on these parameters, we can designate a particular water whether it is fit for a suitable use or fit for disposal or not. So, there are let us say guidelines and standards available for discharge water quality for say if you want to discharge water to a treated sewage to or treated industrial waste to a river, what are the allowed parameters for that water. So, like what is the permissible limit for BOD? BOD is say should not exceed 10 or should not exceed 30 milligram per liter. Similarly, what should be the minimum dissolved oxygen in that water? What should be the what should be the maximum solid concentrations in that water? Maximum concentration or level of different metals in that water. So, that way the overall quality of a water or in our case wastewater is checked, and then we designate that water whether it is suitable for discharge, suitable for reuse or needs further treatment, what are the parameters that are exceeding the standards. So, accordingly we fix on the type of treatment also. For say if your suspended solids are very high, so if you are putting and trying to give a biological treatment, that is probably not going to work. So, for the suspended solids, what are the suitable treatment, or organic matter is very high, so what kind of treatment should be provided. All these are decided based on the quality of the water or wastewater. There are discharge standards available from the different agencies, different norms. Even the Bureau of Indian Standards has designated discharge standard for sewage discharge. Similarly, the different type of, as we discussed earlier also, so the different type of wastewater or the wastewater received from different sources are likely to have different characteristics. Different characteristic means the different values of these parameters. So, for say a wastewater, domestic wastewater which is coming in may have a BOD ranging from say 80 or 100 to 300, 400 or 500. Okay. However, a waste coming from let us say distillery will have very high values of BOD, okay, could be in a few thousands, okay, or even at times even in lakhs. So, that way we can have very particular values of BOD and COD depending on the source of the waste. We will share some of the typical characteristic of waste received from a few industries, waste received from the municipal sewage in the lecture materials along the course. However, for this particular class we I want to utilize this time for solving some of the practice problems. Okay. So, based on the discussions that we had in the week so far, in the previous 4 classes in this week, we will take up few practice problems and we will try to solve it here. To begin with, the question is the question that you are seeing is basically a glycine undergoes a reaction in the presence of oxygen. So, this is the reaction which is taking place. Okay. This should be O2. Okay. So, we need to calculate the theoretical COD of 890 milligram per liter of this solution. So, remember we discussed how theoretical COD can be estimated. So, if the primarily compounds are having carbon, hydrogen and oxygen, we can estimate the required amount of oxygen directly. We discussed that during the class. For different other organic matters like this has a nitrogen and all that, so it will not fit directly to that formula, but anyway we have been provided a equation and we can use that equation for determination of theoretical COD. So how we can use this determination? Now if we see, let us say the compound that we have, what is the molecular weight of this compound? Now you can quickly see there is 1, 2, 3 3 carbon, so 12 into 3, that makes it 36. There is 3 plus 2 5 plus 1 6 plus 1 7. So there is 7 hydrogen, that makes it 7. So this is for carbon, this is for hydrogen. There is 1 nitrogen, so 14 into 1, that makes it 14, and there are 2 oxygen molecules, so 16 into 2, that makes it 32. Okay. 1 2 plus 2 4 plus 7, right. So if we add these numbers, what we get is 4 plus 2 6 plus 6 12 plus 7 19 and 1 1 2 and 3 3 6 plus 2 8 89. So the molecular weight of this compound is 89, total molecular weight. Okay. And so this if you see the stoichiometry of this reaction, this 89 gram or whatsoever unit you can take, it is basically molecular weight. So the 89 gram is reacting with 3 moles of oxygen, it is reacting with 3 O2. 3 O2 means 6 into 16, so that makes it 96, right. So this 89 gram of your glycine is reacting with 96 gram of oxygen. 89 gram of glycine will demand 96 gram of oxygen for its oxidation purpose. That is why now we can see that 1 gram would need obviously 96 by 89 gram of oxygen. Okay. Now what is the strength of this solution in water? The strength is 890 milligram per liter, right. So 1 gram will need 89 by 90 96 by 89 gram of oxygen, okay, or 1 milligram similarly would need 96 by 89 milligram of oxygen. So the one that we have 890 milligram per liter of your solution would need how much? 96 by 89 for unit and into 890 similarly milligram per liter. Okay. So this is mass by mass. We can similarly say this much milligram would need this much milligram, forget about liter yet, but this much milligram is available in 1 liter. So practically 1 liter of solution containing this much of containing 890 milligram of glycine will, the same 1 liter of solution will exert a demand of oxygen for 96 by 89 into 890. So this gets cancelled and this comes total as 960 milligram per liter. So this becomes the theoretical COD of the sample. So that is how we can actually calculate the theoretical COD. Okay, this was an example for calculating theoretical COD. Similarly, we can, if such reactions are given to us or if we know the compound and we can sort of set up a stoichiometric reaction with the oxygen. So theoretically we can compute how much oxygen demand would be there or how much oxygen is required to react with that particular organic matter or that particular compound for which we want to estimate the theoretical COD. Okay. So that is how this concept can be used. Okay. The next problem that we are going to take is on the solids estimation. Okay. So, we discussed the different type of solids also during one of the classes this week. So, this is a question which says that we need to perform the solid analysis using a influent sample volume of 50 milligram 50 ml, okay, and that has resulted in these observations, which observations are given here. We had the blank weight of an evaporating dish as 54.6423 grams and the weight of evaporating dish plus residue after evaporation. So, once we add these residues, filtered residues, because residue will come after the filtration. So, this plus or water residues after evaporation as this, and weight of evaporating dish plus residues after ignition is this. Okay. The weight of Wattman glass fiber filter paper is also given, and the weight of glass fiber filter paper and residues after drying at 150, and weight of glass fiber filter paper after ignition at 550. So, these 6 different weights are given to us. This evaporating dish, this is actually like it is not is specifically mentioned in the question. However, this evaporating dish will eventually contain the residue that it is containing is once we filter the water. So, the filtrate that is coming into the evaporating dish, and when we are filtering the water, so the amount that which is getting trapped on the filter paper will come on the glass fiber filter paper. So, these 3 belongs to this group which is primarily containing suspended solids. While the first 3 belongs to the evaporating dish which primarily contains the dissolved solids. Okay. Now, then how we can analyze or how we can determine these different parameters. Okay, so for this purpose, or actually this one of the other things that it is not specifically mentioned in the question, though generally it should be provided that whether it is the filtered this thing or coming, or the total water can also be taken. So, in that case this will be the first 3 set will belong to the total solids. Never mind, we are considering that it is the filtrate part. So, these 3 are for the dissolved part and these 3 are for the suspended part. Now, if we see the dissolved part first, right. So, the weight of evaporating dish is the blank weight is given to us, and then once it is the filtered, now the blank weight is, let us say, the E0 of the evaporating dish. Then after getting water in this and evaporating it at 104 degrees Celsius, this is, let us say, E1, and the after it is ignition, let us say this is E2. So, the difference of E1 minus E0, okay, is the one which is the total part which is there, because the water has evaporated and all the solids had retained in there. So, this way we can see the difference in here. So, this is practically 0.7184 54, and this is 54.6423. So, if we subtract, this is 1, this is 6, and 11 minus 4 7. So, 0.0741 is the difference. This difference is practically coming from 50 ml of sample. We divide it with the volume. Okay. So, this gives us the total dissolved solids, the solids which are in the dissolved. So, that way our TDS becomes 0.0761 grams or we can consider that in a milligram also, let us say. So, that will become 76.1 milligram. So, this becomes our TDS becomes 76.1 milligram in 50 ml, or say 76.1 milligram in 0.05 liters. Okay. And then we can divide this number by 0.05 and get the total dissolved solids in milligram per liter. How we are going to determine the from this same number we can actually determine the difference between E1 and E2. So, instead of that will give us the part which has evaporated, the difference between E1 and E2, because E1 has the both fixed as well as volatile part, while E2 has only fixed part. So, if we differentiate between E1 and E2, or if we take the E1 minus E0 divided by 50 ml, sorry, E1 minus E2, okay, E1 minus E2 divided by 50 ml. So, E1 essentially contains the fixed part plus volatile part, while E2 contains only the fixed part, volatile has escaped. So, fixed plus volatile minus fixed, what will be there is volatile. So, this is going to be the total, means we are talking about the dissolved solids here. So, it is going to be the dissolved volatile solids or volatile dissolved solids, you can express VDS. So, the VDS will be E1 minus E2 by 50 ml. So, the difference of these two, now you can see that 14 minus 8 becomes 6, and then this becomes 7 minus 1 6, and 11 minus 8 3. So, 0.0366. So, this number becomes that way, or we can say 36.6 milligram divided by 0.05 liter. So, you dissolve this and you get the volatile dissolved solids. Okay. And if one needs fixed dissolved solids, so the difference of TDS and VDS will give us the fixed dissolved solid. Okay. Now, similar calculation can be made for here also. So, for the filter one, let's say this weight is F0, sorry, the weight of blank filter is F0, this is F1 and this is F2. So, the difference between F1 and F0, which is coming from 0.05 liter, okay, will be, so this F0 is the blank filter paper, while this is the suspended solids. So, it is actually the total suspended solids which is coming on the filter paper, total suspended solids, or we can say it is a combination of fixed suspended solids plus volatile suspended solids, right. So, this is with the total suspended solids, this is blank. So, what you will get is TSS from here. Okay. We can we can take the difference out from here. So, this is 1.5434. If we subtract this, what we get is 1, and 12 minus 3 9, and then 5 minus 4 is 1. So, this is what we get. Okay. So, F1 minus F0 will be actually 19.1 milligram in milligram, because this is in gram. So, milligram divided by 0.05 liters. So, we divide this and we get in milligram per liter, that is our that is our TSS. Similarly, we can estimate the because what F2 is, F2 the volatile part has escaped upon putting in furnace, and what is F2 is left with FSS only. So, if we take the difference between F1 and F2, that will give us the volatile suspended solids. Okay. So, the difference between these two, if you want to determine now, so that will be, instead of this, if we take the difference between these, so what we get is 4, 12 minus 3 is 9, and 0 and 0. So, 0.0094, or we can say 9.4 milligram divided by 0.05 liter. So, that will give us the volatile suspended solids. Similarly, we can estimate the fixed suspended solids by subtracting these two. So, we got that way what we got so far is volatile suspended solids, total suspended solids, fixed suspended solids, total dissolved solids, volatile dissolved solids and fixed dissolved solids. What else is needed? The total solids. If we add these two, total suspended solids and total dissolved solids, we are going to get total solids. So, total solids is total suspended solids plus total dissolved solids. So, whatever are the numbers, we can add them and get the total solids that way. Total volatile solids we have estimated. So, no, total volatile solids if you want to estimate. So, the total volatile solids similarly will be fixed dissolved volatile solids and suspended volatile solids. So, volatile suspended solids plus volatile dissolved solids. Now, we have estimated these two also. So, we can add and get the total volatile solids. Total suspended solids we have already estimated, volatile suspended solids are also estimated and total dissolved solids are also estimated. So, that way we can estimate the different species of the solids for the purpose, okay. And that is how we can sort of do these calculations. So, then there is another practice problem on the BOD estimation, okay, a simple problem. So, this says that the series of dilutions were prepared in 300 ml BOD bottle. So, the volume of the bottle is 300 ml. Okay. Now, if you see the dilution, so there is 3 ml seed. The volume of seed in this experiment means that how much was the sample. So, 3 ml sample, but the bottle was of 300 ml. So, rest is filled with the dilution. So, that means this 3 ml seed was made up to 300 ml with by adding 297 ml of dilution water, okay, or rather aerated dilution water which is used typically in this case. Similarly, this is 6. So, for this we 294 ml would dilution water would be added, this is 9. So, 291. So, all will be made up to sort of 300 ml. Now, if we see the dilution factor, so here the dilution factor becomes how much time it is diluted? It is diluted to 300 from 3. Similarly, this was diluted to 300 from 6. So, dilution factor of 50, dilution factor of 100. Okay. This was diluted to 300 from 9. So, dilution factor of accordingly we can calculate 33.33, and this was diluted 300 from 12. So, this was the dilution factor for the different samples. Okay. We have been given initial dissolved oxygen in the bottle. So, for BOD purpose, if you recall the discussions that we have, we will have an initial dissolved oxygen means once we set up a sample. So, there is let us say seed and bacteria. So, we monitor the dissolved oxygen at initial level and then after few days. Okay. So, if let us say it is a 5-day test for say typical BOD. So, what is the dilution after 5-day or final dissolved oxygen. So, initial dissolved oxygens are given for each bottle and final dissolved oxygens are also given for each bottle. We can compute what was the depletion, the difference between initial and final, and then we can determine the BOD of each of these test sample. So, how BOD will be determined? There is initial DO. So, say DO 0 minus DO on that particular day, in this case it is final DO. So, let us write DOF divided by the how much times it has been diluted that way. Okay. So, the actual sample volume is 3. So, this is coming from 3 and this has been diluted to 300. So, this will actually be the sort of for let us say case 1, okay, or bottle 1. So, BOD is going to be this one. Now, if we say the difference in initial DO and final DO is 2.75. So, 2.75 into 300 divided by 3. So, that makes it 275. Okay. So, that way we can estimate the BOD values for the different all these different samples which are given to us. Okay. So, now let us see the BOD of the samples. So, here it becomes 2.75 divided by 3 into 300, which is 275. In the second case it becomes 4.1 into 300, 300 is there volume and this is 6. Okay. So, this becomes 50 or 41 into 5. So, 5 ones are 5 and 5 fours are 20, 205. Similarly, here it is 5.5 into 300 divided by 9 and this becomes 6.5 into 300 divided by 12. This is 300. So, that way we can estimate the BOD values for these different dilutions, okay, and then determine the BOD of each test sample. So, that will be the BOD of each test sample and then of course, we can take the average BOD. So, summation of this divided by there are 4 samples. So, total sum of this divided by 4. Okay. So, like this become 275, this become 205. If you try to solve this, so this becomes 550 into 3 divided by 9. So, 550 by 3, 3 ones are 3, 25, 8, 10 and 3, 9.33. So, this becomes 183.33 and for the last one which is this becomes 650 into 3 by 12, 4. So, 650 by 4, 4 ones are 4, 25, 6 are 24 and 10, so 2.5, 162.5. Okay. And if you want to take the average of these, so 275 plus 275 plus 205 not 0.205 plus 183.33 plus 162.5 and this divided by 4 is the average BOD. Okay. So, this will be 480 plus 6285 5 345.83. So, this total will be 825.83 roughly divided by 4. If you divide this by 4, so this becomes 200 around 207 or 6. Okay. So, approximately 206 or 7 milligram per liter would be the average BOD of this sample for which these values are given. So, that is how the BOD can be estimated. So, these were few examples that we saw how the DO estimation is again simple based on the titer-metric precision, or these days just we monitor the DO by the probes as were discussed during the class. MPN is a bacteriological processes, so that is depending on the counting okay, how many tubes are positive, how many tubes are negative, and then values is estimated based on this. But from the other major parameters, this is how BOD can be estimated, or COD can be chemically estimated or calculated. One example we have seen from this. We will be happy to share or discuss few more questions in the as in the form of lecture materials or so, and we will happy to have further discussions in the forum on this. So, with this we end this week's discussion here, and we will start discussing about the next topics, how the when the waste comes into the nature, how nature takes it, some self neutralization processes and all that in the next week. Thank you.